Okay. I'm just doing a random live because I may have some time. I don't know. We'll see what happens. Either way, at the latest, I'm gonna stop like at 6 or 6:30, if not sooner. So this is chapter 3. Structuring your classes with U and L. In this chapter, we'll learn about drawing classes in U and L, drawing inheritance and other relationships, building components with U and L, and deploying software. So some of this is going to be a review from when I took advanced object-oriented programming, so that'll be good. Okay. When you use the Unified Modeling Language, UML, to design software, your diagrams have two aspects. One is static, and the other is dynamic. The static diagrams represent the things that do not change while your application is running. For example, a class does not change while the application is running. When you write the code, you write the class name, number of variables, and a number of functions, and you notate what is private, protected, and public. After you compile the application, this information does not change and remains static. This is in contrast to the information you represent in the dynamic diagrams, where the information can change. Dynamic diagrams include things like object creation and deletion, as well as object collaborations, which are the side note with the parentheses. Objects working together or collaborating, conspiring, plotting, and scheming like good little classes. In this chapter, we discuss the 3 types of static diagrams. Class diagram. A class diagram represents the different classes in your application. Component diagram. A component diagram represents the major parts or components of your application. Deployment diagram. A deployment diagram represents the different computers and hardware that your application will ultimately run on. Okay, I do break for chat. Oh, okay, thank you, Adrian. That's nice of you to see. I don't know. Anyway, moving on. So remember, in this chapter we talk about the UML diagrams. And although you'll rarely hear us say this, one thing we don't talk much about, at least not in this chapter, is the methodology. We cover that topic in Book 2, Chapter 2, which I just finished reading last slide. UML is a language used to design software. A methodology is the process you use to design software. The process we recommend is the Rational Unified Process, RUP. In this chapter, we discuss the diagrams, and we mention the parts of the process where you might use the diagrams, so you get to make lots of pretty pictures. That's fun. Hi, DJ. I don't know if you mean if I can read the book or the chat or both. I kind of just have to try to multitask. Anyway, I come up for air every so often. So this is the next page right here. Again, in case anyone missed it, this is right here. C ALL-IN-ONE For Dummies. It was like published in 2014 or something, but there's still some parts that are applicable. Alright, here we go. Drawing classes. Like so many things around us, objects can hold other objects inside of them. For instance, an alligator may have inside it, well, that's probably not the best example. Rather, a printer object would have a toner cartridge inside it. These could be separate objects, each belonging to its own class. One might be the laser printer class, and the other might be the toner cartridge class. In this sense, the two classes are connected. The connection is not by inheritance, nevertheless, they have a relationship. You can take this relationship a step further. We have a container of blank writable CD-ROMs. Um, Sorry if you don't know what those are. They're everything digital. Mm. Or CDRs. They really do. Hopefully, hopefully they updated this to make it a little more relevant examples for some of this. The container can be an instance of the class CD-ROM holder. The items inside the container might each be an instance of class CDR. In this case, a single instance of CD-ROM holder might contain several instances of CDR. So whereas the laser printer instance contains a single toner cartridge instance, the CD-ROM holder contains several CDR instances. Another example is the class Porsche that's parked in our driveways. It contains exactly 4 instances of Goodyear tire. Yes, we're dreaming. And so you can see several possibilities here. Exactly one instance. An instance of a class might contain exactly one instance of another class. Fixed amount of instances greater than one. Each instance of a class might contain an exact number of instances of another class. This number does not change between instances. Varying number of instances. Each instance of a class might have a different number of instances of another class. This amount might vary from instance to instance, and it might even change over time for a single instance. Am I having a good day? It's going. I just sort of started a new job and growing pains. Let's just put it that way. I'm sure it'll be good soon. Just gotta figure out like another job though. Like in addition to that, which means less time for lives. Okay, DJ the one, why are you hey? What's up? Last stream it was like 2 hours and I barely got 3 page read. I'm trying to get a little more reading in. Did he bounce to the ounce? Probably. Moving on. Let's see. As for the final item, you can see that when we remove this CDR instance from the CD-ROM holder instance, the number of instances the holder contains decreases by 1. Or if we put a CDR instance back, the holder goes up by 1. If we buy more and refill the holder, it goes up by more than 1. But with the Porsche that we truly believe is parked outside, the number of tires stays the same. As you analyze the classes to build your application, you might find some disagreement here. When we go to buy new tires, the car is raised off the ground, and mechanics remove the old tires one by one until no tires are on the car. Then they install new tires one by one. Thus, the number of tires isn't fixed throughout the life of the instance. But how you build your class depends on the needs of the people using the application. You need to consider that aspect, and you can therefore treat the number of tires as fixed. Or you may need to include the tires replacements, in which case you would not treat the number as fixed. And here's another example. If you're writing an application for a racing game or simulator, you may want to have the ability for 4 wrecks to occur and tires to come off the car. Then you would need to vary the tire count. No? No other things in the chat? Okay. Remember, how you design your classes depends on the situation. Always assuming the same thing for a similarly named class. Oh yeah. Always assuming The same thing for a similarly named class as it appears in different applications is not practical. Some applications may require a class to be different from a class in another application, even though both classes happen to have a similar name. Another kind of relationship is inheritance. The laser printer class might be derived from the printer class. Inheritance can also be complex. You may have a class and also have two classes derived from it. One of these two classes might have two classes derived from it, and another might have only one. And from there, you might have no more classes derived. C++ offers great flexibility. Okay. Technical stuff. You can look at design issues in another way. A class is kind of a classifier. In this regard, you can imagine inheritance showing different words for kind. One would be class, and one would be classifier. Then class is derived from classifier. Another classifier is type, and therefore type would be derived from classifier as well. Remember that integers are types. For example, from this perspective of the meta information or metadata, you could think of int as an instance of the classifier type. And you can think of laser printer as an instance of the classifier class. And the particular printer on our desk, then, is an instance of laser printer. This requires an abstract way of looking at things. But if you can keep up with this system, you're ready for some serious class designs. That's because you'll understand how classes all fit together in the greater scheme of things. Good day, but random thing to say. Okay, I'm waiting. KFC was wanting to know. I can't do the dancing. I'm not really feeling it, but also I was a little too a little too late back on Sunday with the TikTok live stream. Trying to give my neighbor a break. Okay, I'm still hanging on the butt there. As far as the word that is there in the chat by Man in a Van. Okay, then. Technical stuff. You can look at design issues in another way. A class is kind of. Did I say that? I sure did. Alright, cool. Okay, mapping classes with UML. You can create a UML diagram that shows several classes and their various relationships. Take a look at figure 3.1. The figure shows three classes: printer, laser printer, and toner printer. Pay close attention to the lines connecting these three classes. The lines are different because these classes relate to each other in different ways. Okay, I kind of forgot to share. This is the page I just read off of. I know it's really not the best lighting, but I'm really trying to rest my eyes. And that's why I'm reading anyway. But hey, if you happen to find this somewhere. Oh yeah, that is some blurriness. I could change my lighting, but I don't like it. Okay. So then the figure 3.1. I guess I could try and do that part. Okay, fine. Hi. Light my face. Okay. When you look here, too much light. They're talking about this guy. This here. See, there's the printer. And then underneath that is a laser printer. And there's an arrow that is going on up. And notice it's just an arrowhead. That's what's going on at the tip gate. I should say the right at the bottom? Right at the bottom. Okay, so then what happens is there's this other guy that's pointing to, right here. Is this backwards? It's probably backwards. It sounds like, it looks like. Is this backwards for you guys? Is this text coming in the wrong way? Anyway, the point is, I'm kind of telling you. So there's this thing right here that's got nothing on top of it. That's what's pointing on over to the laser printer. So the thing that's pointing over to the laser printer is the toner cartridge. And instead of just regular arrowhead, that's got this like diamond thing going on. Oh, thank you. Okay, so then, okay, fine. I guess I'll just blind myself and you two a little bit. I can read a little better without the darkness. Okay, so it says first line connecting printer and laser printer shows inheritance. The fat hollow arrow points to the base class. Thus, laser printer is derived from printer. Okay, technical stuff. Although you won't hear us use the term much, an opposite to the term derived from is generalized. Thus, if laser printer is derived from printer, another way to say this is that printer generalizes laser printer. The idea is that printer is a general form of laser printer, and laser printer is a specific form of printer. The reason we prefer not to use the term generalize is that when you create a hierarchy of classes, you typically create the base class first, then you derive a new class. So to us, the term generalize is counterintuitive, and our brains don't do well with counterintuitive ideas. However, we should add, in all fairness, that a common way to come up with classes is by noticing similarities between two classes and then coming up with a single class to serve as a base class. So in this sense, generalization makes sense. Oh, hi. That explains why I cannot read your name. Nice to meet you. Person from Russia. In this second line, the end with the filled diamond refers to the whole that contains the part. Thus, laser printer is the whole, and it contains the part toner cartridge. Notice also that two numbers are below the composition line. The one on the left means that one laser printer instance is in association. Oh, that's good to know. Okay. The one to the right means that one toner cartridge instance is in association. So that wasn't a thing I really had to like do much in when I was taking an advanced object-oriented program, but that's nice to know because I'm looking forward to hopefully by the start of next year getting into doing a personal C++ project using some of these videos I've been making since the summer. So we'll see. I don't know about these lives. These are kind of long, but like they're short ones. Okay, then. Now look at figure 3-2. I don't know if this can reach without a lot of dropping and I guess I can just do that. Ugh. Oh boy. Let's see here.
From the calendar, Dr. Whitman, drop follow-up starts in 10 minutes.
Okay, now look at figure 3-2. Here you have a diamond and a line, which again means composition. But this time the Porsche class has a 1 by it. And the instance of Porsche will have exactly 4 instances of Goodyear tire. In other words, one car has 4 tires. Oh, that's cool. Okay, here, I'm going to try to at least remember to show off the... Oh, no. Oh, you know what? That's what I should be doing. Okay, hold on. This is fun. It's gonna be great. I can really empathize with all of the, online teachers during like the lockdowns, because this is kind of, if you don't have the right setup, this is really tough. Hold on, that was supposed to flip. Okay. I'm sorry, I have a messy time. Life is kind of oof. All right, so here you go. That's what I was trying to show. So that's your figure 3-2, and that's the diamond and the line combined means composition. So in this case, and now you can see it in the correct order, so that's good. Um, I still don't know what man in a van was saying, but that's okay. So in this case, the Porsche has the one, because there's only one Porsche, and like if they said in the print, like there's 4 tires. There's a 4 there because there's exactly 4 Goodyear tires per every Porsche. Best case they were seeing, but whatever. Okay. Now let's look at figure 3. Again, you see an association, but this time is between the pasture class and the cow class. But in this case, the pasture class has a 1 by it, and the cow class has an asterisk by it. The asterisk indicates that any number of cow instances can be associated with any single pasture instance. In other words, a single pasture can have multiple cows running around on it. When you put an asterisk in the UML diagram, it indicates that any number of instances can be in the association, including 0. Therefore, a pasture might have no cows in it. They're all in the barn being milked. Or just one might be in the pasture, or 100 cows may be out in the pasture lounging around. Okay. Just more jankiness. So much jank. Alright. Okay, so in this case, we're talking about cow and pasture. So that's like this guy right there. So there's the one by the pasture and then an asterisk by the cow, because there's an undefined number of cows. Could be 0, could be more, it could change, as the cows get eaten and get milked in, or getting a nap, or food time, or what have you. Okay. So yeah, figures are 3. Many instances of a class with the asterisk nearby can be associated with the class with the 1 nearby. Other possibilities for denoting the number of items in a relationship are also available. These possibilities are called multiplicities. Table 3-1 lists them. Okay, I'll just pretend like I'll just go to that part. Okay. I swear, it's just so better the other way. Okay, fine. Am I like muting myself by accident? Is this the problem I'm having? No? Okay, cool. Alright. So right here on the table, that's what it's talking about. I'm going to hold out just a bit in case anyone's interested in trying to read it. I know it's shaky, sorry. It's only so much I can hold this way. Alright. Messy times. Okay, flipping this back this way. Okay. So it says table 1, multiplicities. Then it says symbols, and then what they mean. So 1, it means exactly 1 instance. Okay, so this is sounding a lot like what I was doing in distributed systems. And that is exactly n instances where n is any number. I suppose it could be 1, 2. Okay then. Then there's n dot 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 to n, which means anywhere from m to n instances allowed. It could be 0 to 1 or 1 to 10, for example. Then the asterisk, it means any number of instances including 0. And then there's a 0, dot, 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 and then asterisk, and that means a number of instances including 0, which is the same. It's just saying asterisk by itself. For example, if you have two classes, one called vacuum and another called extension tube, and you see one on the side with vacuum and one dot 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 for, and this was just dot dot, whatever, on the side of extension tube, that means for each one instance of a vacuum, you can have anywhere from 1 to 4 instances of extension tube. Okay. Not very lively chat today. On the plus side is I get more reading time, but also that was kind of fun. Oof. Okay, hold on. Let me try to not totally break things. Is that possible? No? I should stop trying that? Okay, good. Oh, hi, Ryan. Let's see. Oof. Okay. So, technical stuff. But wait, we thought these class diagrams were supposed to be static, not dynamic. And that's true. They are still static diagrams. Although the line between static and dynamic is blurred, we could go into a big philosophical explanation about why class diagrams are indeed static. For example, you write a class that contains a single array, and that does not change. But instead, let's say this. Just consider a class diagram to be static and recognize that some blurry distinctions exist. It's not a big deal. Inheriting UML. If you want to specify inheritance in UML, you simply draw an arrow from the derived class up to the base class and don't fill in the arrow. But you can show other types of inheritance with UML. Oh, so UML is just something that I got an opportunity to do by hand when doing my advanced object-oriented programming course, but I couldn't figure out how to actually use the software, nor did I have time to really try to learn how to do it. I was so busy banging my head in the wall learning C++, which is why this is a review for me, because when I was in the middle of using C++ for advanced object-oriented advanced OOP programming, of course, and also for my big data class, it's like I'm just so busy trying to use it to make things happen. I don't really have time to like think about the why is this happening. So that's why I'm like, I saw this at the library. I'm like, oh, I gotta like see this, but it's been taking me so long to get through this. My last renewal, automatic renewal, is almost up on this, so I'm gonna have to go back to the library to check it and check it out again. Probably this weekend. Okay. So then it says, if you want to specify that a base class has an abstract virtual functions, you specify those in the class by using italics. Oh, okay, that's good. Yeah. Virtual functions are interesting because you can do a lot with making templates and stuff like that. Or like, anyway, that's one of the things that we're learning in advanced object-oriented programming, because you can make a starter. Well, that's another different way of, there's this thing called design patterns is the main thing, and so there's all kinds of methods that you can use to try to like get things start with your coding when you're using an advanced when you're using object-oriented programming, so it's such as C++ or like a Java, oops, I think I'm like a Rust, if I remember correctly. But I was just kind of just trying to, because I had familiarity with C# when I was taking the video game programming classes that I took, and then previous to that, I had experience just doing C regular. So I'm like, let me try C++. It can't be too hard. It was for a while there, and then I started getting the hang of it, and then I was like, ugh, a little less of annoyance. It just does errors. You get so many errors. If you don't know what you're doing, you just error. And then every time you gotta make a little change, error, you got it. But I was able to get through it. I was able to figure out how to do the troubleshooting. Dude, I am. Goodness gracious. Alright, Ryan, thanks for coming to listen to me blabber for it. You have a good night. Maybe check out something I do later. I have no schedule. It's random. Subscribe if you're interested. If it's getting the live notification. I also have dancing shorts. I also have TikTok dancing videos. That is also Becky828. Alright, you're probably done, but bye, Ryan. Have a good sleepy times. Oh, great. That works too. Thank you. Thank you. Bye. So let's see. If you want to specify that base class has abstract virtual functions, you specify those in the class by using the talks. Okay, right. For example, figure 3-4 shows a base class called person. This is an abstract class because it contains an abstract virtual function. Work. The function is abstract virtual because I'm gonna have to. Now that, like, when I finish this, the next step would be to go back to get that text that I was reading through for advanced object-oriented programming, because now that's going to make a lot more sense. Like every time they talked about C++ in that book, should make a lot more sense. Oh, I do apologize. There's a lot of I spend my days at work dealing with a lot of kids making all kinds of sounds, and then I come home and sometimes there's kids making a lot of sounds. It's fun. Hmm. But no, no one's being injured. That's just how they like to play. And our family issues? I don't know. I'm not sure. Okay. This function is abstract virtual because it is in italics, and thus the class itself is virtual. Remember that a class that has at least one abstract virtual function is therefore itself abstract, which comes in handy when you're trying to, like, okay, so same thing with like Java. When you're trying to like set something up to only be able to have certain features, you do, in this case, C++ an abstract class, and then you make sure that the thing has to derive from that thing. So that means if there's anything at all that is trying to use the wrong permission level, it'll automatically ding. I'll be like, no, bro, we're not doing this. So that's like kind of a handy way to try to make sure that certain things are set into place, like from the get go, because it literally will not let you do anything if it doesn't match up exactly with what basically the Scribnotes version is in the abstract class. And so I'm trying to do. It's been a while since I Java, like a long while since I Java. So it's like there's something similar that you do, because one of the whole basic concepts of object-oriented programming is you're able to inherit. You're able to have inheritance going on. So that means that, like this was saying earlier, it's able for one class to then be the parent of another class, which then can be the parent of another class. So you end up with this like line of ancestry kind of deal, but you can't really have that, which is a C type of thing. That's just more like a one-dimensional sort of thing. But C is great because it's got a lot of power going on. There's a lot you can do. You can make operating systems and such with it, and our embedded systems. But the major problem with the C, you have to be very, very, very sure that you're dealing with the memory correctly. That you're doing, because unlike a Java, which does the garbage collection for you, you gotta go ahead and make sure that you're having your destructors. Destructors are also a thing you can implement here, as it's going to be talking about more in the book, but it's like a must-have in C, whereas with this is probably a nice-to-have, but it has a safeguard that's similar to Java, so you're not going to end up with a very bad memory leak and end up crashing things. So much crashing. Okay. Um. Okay, we're reading. Oh, yeah. Oh yeah, messy. I need another hand. Okay, hold on. Oh, it doesn't help that this thing will totally fall on my head. That would be comical. I'm sure you guys would get a laugh, but maybe that shouldn't. Somebody did something naughty. Do I feel like naughty right now? Not really. Okay. So this says, what is, hello, I'm trying to put light. I'm missing the, step into the light. There it is. Oh, I was getting light. This is my phone wasn't. Okay, great. So this right here, this is what I'm reading about now. The person, the bank robber, the middle manager, etc. So that says, messy. I'm so messy. Just got all my personals out. Privacy. Okay. Let's see. If you want to, okay. So, figures before, you can show abstract classes in UML by putting a method in italics. So at the top it says person, and it says the plus, which means, pretty sure it means private. They went over that in the first book of this. There's 6 books in this. Alright. So then a person derives a bank robber or derives a middle manager. And so that also has a function, which is a virtual function of work. Hi, Jamie. So it says the 2 classes derived from person, bank robber and middle manager. We just thought those made for an interesting combination. Each override the work function, therefore they are not abstract, and thus you can create instances of bank robber and middle manager. Yeah, the last thing you want to do is try to like, oh, thank you, Jamie. That's very kind of you. Awesome. Thanks. Oh, just so you know, random lives, I have no schedule. But additionally, what I have been able to manage to do lately, I am not a solid YouTuber. I'm more of a YouTube watcher, but I'm trying. Um, but yeah, lately it's been about the dancing shorts. Previous videos of dancing that are longer than short length. Previous mixed hair tutorial. Mixed chicks hair tutorial, I should say. First, a mixed chicks product. And I don't know if you've ever seen Once Upon a Time, but I used to do reviews back when that was still a thing. That was a fun time. And karaoke, but I have a feeling that that no longer is a thing. Karaoke party used to be a thing, but me these days, not yet. Maybe one day, I don't know. I just kind of maybe wasted 10 years. Maybe, I don't know. We'll see. Pursuing a Master's of Science in Computer Science. And the job market is not quite as I was expecting it to be. But additionally, I love teaching, so I kind of like want to keep doing that. So it's like, if I could figure out a way to like mainly focus on continuing to work with the teaching, K through 12, college, throw in some software development and or data science in the mix, that would be a fun time. I like staying interested in things. So, not yet. TLDR, no. Oh, alright, thanks. I'm just kind of feeling like I'm wasting all my dang time lately. I had it in my head, all kinds of different, but that's okay. It's been nice getting the opportunity to go and explore some YouTubing and some TikToking, and looking forward to figure out ways to put that up in some C++ projects. Looking forward to. I got a little time doing computer vision in one of the classes that I took, and I learned about multimedia networks in another class that I took. So it's like, oh, distributed systems. Like, oh, I might be able to make some software that can pull the videos from the YouTube and the TikTok and do things with them. It'd be a fun time. People want to just be unkind with the messages or something like that. I don't know. Is that two different messages that were over you? Okay, so I do have a heart out for dinner time. I'm just getting home, so it's the my ear's weird. 6:12. All right, got a little bit more time. I will set a reminder though. All right, friends. I feel kind of peckish. Just a bit. I will say 20 minutes on the clock. And I don't like to leave in the middle of a section, so I'll probably close out whatever section I'm in and then go get some food time. Alright, let's see. Remember, you may have noticed that so far we have not mentioned a way to specify a virtual function in UML. You could specify a member function as abstract, but what about plain old virtual? You can't. The virtual keyword is unique to C++, and the word simply means that you can override a function. So how do you specify virtual? Many case tools include an option in the model that lets you specify a member function as virtual. Okay. Aggregating and composing classes. When you associate two classes but not by inheritance, you can do it in two common ways: composition and aggregation. Consider the laser printer class and its association with the toner cartridge class. A toner cartridge is a fundamental part of a laser printer, but a toner cartridge can't be inside more than one laser printer at a time. This is composition. Aggregation, on the other hand, refers to two objects that are more loosely connected. In an office, you may find hundreds of computers and a dozen or so laser printers. The laser printers can function on their own, and they interact with many different computers. Meanwhile, the computers can each interact with many different laser printers. This is a much looser connection. This is aggregation. But this does not imply that composition is only for one-to-one relationships. Oh, I will say, if I get a call from my boyfriend before that timer, guess what? That means goodbye early time. Okay. So but this does not imply that the composition is only for one-to-one relationships, and that aggregation is for many to many. Instead, composition simply means a much stronger, tighter relationship. A toner cartridge is an intimate part of a printer, and therefore, I was thinking merge in my head, and then they went and said intimate. Like, okay, I see where you're going with this, authors of this book. Oh, yeah, you don't know that part. John Paul Mueller and Jeff Cogswell, they're the authors of this book. They're funny. That's probably why I like this. It's a fun read. They're like very STEAMs. It's very STEAMs. It's very science, technology, engineering, arts, and math. They're like really upping on their figurative language skills. I appreciate that. I got a BA in writing, so I can appreciate some writing time. But this does not imply that composition is only for one-to-one ring. A toner cartridge is an intimate part of a printer and therefore is in a composition relationship. But a printer is not such a tightly integrated important part of a computer. The computer can live without the printer and vice versa, which suggests an aggregation. And you out, I mean, because it will be bored though, as far as the printer. I'll just stay on, it'll say print ready, and I will just keep doing that. Okay, in UML, you can distinguish the two based on the quality of the diamond. Doesn't that sound nice? However, in this case, we're talking about the diamond shape on the diagram, not an actual diagram. I think they meant diamond. I have a feeling, but they just left typo because diamond diagram, diamond diagram. That's hilarious. For composition, the diamond is filled in solid black. For aggregation, is not filled in, it's just an outline. Figure 3-1 through 3-3 show composition. Figure 3-5 shows aggregation. Okay. Okay, I keep trying, and it keeps just like, it's like, oh, are you sure you don't just want to get a little closer to your chest? Like, no, I wasn't trying to show, I was trying to show the page. Okay, fine. Okay, so when you look here, they're seeing on that, there's an outline of a diamond. So that means there's an aggregation. Whereas earlier, when we were looking at the diamond, it was a filled-in diamond. So, what am I missing around? Yes, I am. Hold on. Skipping too many pages. No? Skip more pages than I... Hold on. I'll figure this out. There. Yay. So that's what they were talking about that being the composition. So the toner, cartridge, composed. I guess technically it's composed within a laser printer is the idea. The tires are composed within the Porsche. Ah, see, here's the thing. They can't say, oh, actually, it is a composition and a, oh, yeah, see, that's the thing. This is a review for me, so at least till I get through this book is reading. Because the point is, like, since it's already for me, I didn't want to, like, try to use their stuff and, like, have to relearn. Like, no, thank you. I already have a pretty good system. But that's coming. I just have to finish reading this. Yeah, sorry. I'm not trying to get the cleavage in there. I'm just trying to get the flipping happening, but it's not quite working as it should be. Okay. I hear you, but I had plenty of time programming with C++ and Googling ferociously. I'm a very good Googler. I can find some sources, but I'd rather not go through Errorland as much. And I like having this in my head so I can, like, properly. Because here's the thing, it's called read now, or be in the middle of programming. I have to stop every 5 minutes going, what's this thing? Google. I already did a lot of that in grad school. I'm done with grad school. I should try to make some better habits, I would think. I don't know. No, it's fine. I'm used to those. I seem to be a magnet. Alright, so that's the thing about that. Then they were talking about the thing about the aggregate. Okay, great. Notice that, okay, I was trying to see. Okay, notice that 3-5 is in classes that we put in figure 3. But this time the diamond is not filled. Yeah, I noticed that. I was wondering why. This means that we modified the diagram to make it an aggregation rather than a composition. Oh, okay. So I was on purpose. Composition and attributes. A close similarity exists between a composition and an attribute. When each laser printer instance has its own toner cartridge instance, you have a choice. Drop composition line between laser printer and toner cartridge with the diamond on the side of toner cartridge, or simply give the laser printer class a member variable attribute of type toner cartridge. After all, when you take the composition and write the code for the class, the composition manifests itself in the form of the member. I'll mention that part of this I know, I hear you, but I feel like I agree. There's a good method. I just wanted to take some time now that I have a chance to actually take some time. There's no like, oh, this project's due by this date. Oh, you gotta get ready for this quiz. Oh, you gotta take this test by this, whatever. I'm like, let me just enjoy some reading time. Because I can even tell you last time, like, I used to be avid reader when I was like in junior high, junior high, high school, all the way through. Probably even in community college. I get to regular college, like university college. Sleepy times, I don't know what it was, but it was just like, okay, I guess maybe I just read too many times for sleepy time reasons, and now it's still a thing sometimes. And the same problem with like videos. I'm so used to going to sleep with YouTube that I was trying to like go through a training after I got home yesterday. I was like, oh, I'll go ahead and I'm gonna hurry up and finish watching this training video. No problem. Fell right asleep. I kept waking up. I was starting like, okay, I need to stay awake. I need to stay awake. Out again. It was like, okay then. So I just had to wait till I got to work today and finish that off. But yeah. Oh, what I was trying to say is, uh, I'm looking forward to starting this whole process off using the whole method that they recommend here, but also what they recommend in the advanced book. But then also actually go through the whole thing of doing the UML. What? Happy? I'm just saying. Honestly, I appreciate um the experience. It's not okay. Even if I don't get paid the kind of dollars um I was expecting to be able to do, I still learned a lot. And honestly, being in the computer science thing kind of helped my ability to problem solve more so. It got me over my math anxiety. Had I not decided to get into computer science, I would have never like had like a reason to try and take calculus or calculus 2 or discrete math or linear algebra. And so I would have probably still been stuck in math anxiety land. And then it's like, even though time's been really crazy, I could still manage to function, even though I'm like, why am I functioning right now? It's kind of just confusing. It's kind of broke my head. And it's weird. After all the draw, okay, I'm just gonna start that. Composition and attributes. A close similarity exists between a composition and an attribute. When each laser printer instance has its own tuner cartridge instance, you have a choice. Draw a composition line between laser printer and tuner cartridge with a diamond on the side of the tuner cartridge, or simply give the laser printer class a member variable attribute of type tuner cartridge. After all, when you take the composition and write the code for the class, the composition manifests itself in the form of a member variable. So which do you do? Really, it's up to you, but don't do both at once. Though you must follow one rule, and as we would like it with most rules and laws, this is not strict. If you have a common class that you use throughout your application, one that you might think of as a utility class, and it appears as a member variable in many classes, you probably should make it an attribute rather than show it through a composition line, simply because it will prevent your diagrams from getting cluttered. Remember, when you use UML, you can't have two diagrams showing two conflicting associations. Thus, we can have both figure 3-3 and figure 3-5 in a single UML model. The UML model must provide a consistent representation of all associations within that model, even when the association would be of a different type in another model. Tip. Another way to look at composition is through ownership. If it makes sense for one object to own another object, this is composition. For example, one laser printer instance would have its own toner cartridge instance. Another laser printer would have a different toner cartridge instance. That is, the two laser printers cannot share a single toner cartridge. Thus, you can think of each laser printer instance as owning a toner cartridge instead. In that case, you can use composition. Okay, yeah, that makes sense. Okay. Oh, thanks, Rain. Alright, I still have some time, I guess? Okay. It's just over 5 minutes 30 seconds, something like that. Building components. When you are building software, grouping various classes into components is often convenient. This means creating a library of classes. Most operating systems refer to these collections of classes as libraries, but Windows calls them dynamic link libraries, or DLLs for short. It's unpronounceable, so we just say TLL. Oh, I already know how to. Whatever. This is a whole different message that got flagged? Okay. A library is simply a file that contains a bunch of code that other programs can use. I'm looking forward to making some libraries. That'll be fun. Dreams. Maybe in a year or two. I don't know. It depends on how long. I'm so slow. The other programs, load the library and then call its functions, but nothing particularly magical surrounds the library. It's just a bunch of compiled classes and functions stuffed into a single file. And it's compiled. It's not source code. Or a component might end up in the form of something called static library. A static library is much like any other library in that it contains a bunch of code for your application to use. However, when you build your application a linker, which is a tool that performs the link process, combines the code in the static library directly into your final executable file. This means that your executable file will be bigger than it would be if you link it to a dynamic library. But when you link to a dynamic library, you need to either ship the dynamic library with your application or make sure it's already installed in the user's application. With a static library, you don't need to worry about it. Incidentally, if you're using a Unix system, a static library gets the .a extension, which stands for archive, and a dynamic library gets the .so extension, which stands for shared object. Try the same thing in Linux. If you're doing some sophisticated programming, you can also group classes into a component that you will ultimately put into an object-x control or component object model COM object. These are special kinds of libraries that run on Windows. Therefore, you can think of a component as a generic way to group classes. Figure 3-6 shows a component. It's a box with a couple of additional little boxes to its left. Inside this component, called My Library, you can see that we put two classes. One called C and one called Look. Oh, okay. Alright, I'm trying not to get the... I'm trying to be modest. Okay. Okay, got a book. See, it's hard. I ran out of plants. There's only so many. I don't know, Ryan. I'm just trying to live life best I can, all that. Help people if I can. Gotta remember sometimes I try to overdo the helping. Okay, that's figure 3-6. And that says a component is a box with two smaller boxes added to its left. So that's what that looks like. The bigger box is my library, and then there's a little 1-2 going on, and then there's the little parsec. Oh, I just switched my light mode. Oh no. Okay. Ooh. I like it. That's better. Okay. So things and stuff and things. Right. Okay. And then I'll just hold this up real quick. That's this other guy, figure 3-7. And it says another way to notate components is to use dotted arrows that point from the component to the classes. So that's two different ways of doing that. And then while I'm showing off things, oof, this one, oh no, my shadow's in the way. All right, here. This guy over there, figure 3-8. Oof. It says, I'm not gonna hold it like that. Oh, messy. Okay, hold on. Flipping. Why does that flip so easy? But the other one's like, no. Alright, anyway. So that says figure 8. You can use stereotypes. Ooh. Alright. I show different components working together. That's interesting. Alright. So, how much more time I got? Ooh. Not much. Less than a minute. So I'm going to close out this section. So, which means I'll stop right before deploying the software. Okay, UML provides another way to notate components as shown in figure 3-7. Notice here that we have drawn the classes outside the component, and I've instead pointed, hold on, boo, did I do all that? Therefore, you can combine generic way classes, figures, components, and box. Yes, okay. So we've also enclosed the word reside. Oh, that's cool. In double and brackets. The French use these guillemets in place of double quotes. Okay, that is it for my time. So I'm going to finish off this section. Write it down in case somebody quizzes you on it. And figure 3-7. Another way to notate the components is to use dotted arrows that point from the components to reside. Okay, stereotyping. Most people accept that stereotyping is a bad thing, but in UML it can actually be a good thing. In UML, you can take an existing symbol, such as the component symbol, and slightly modify it to make your own customized version of the symbol. This modification process is called stereotyping. When you do so, you add a word inside the top of the component symbol. You put the word in the double angle brackets like this. In this case, they had the double angle brackets, then the and then the double angle brackets close up. And that parameters HTML. Guillemets, again, one for everybody. In fact, in UML, anytime you see a word enclosed in guillemets, you're seeing a stereotype. Just think of a stereotype as a modified form of the symbol or as your own version of the symbol. When you create a component diagram, you can use stereotypes in your components. Think of it this way. Suppose you have several components that you'll build into a Windows DLL. The same principle applies to other platforms and component container types. Because the component symbol itself doesn't have anywhere to notate that it's a DLL, you can create your own DLL component symbol. You do this by putting a stereotype inside the component symbol. Figure 3-8 shows 3 components all working together. Two will ultimately be DLLs, and one will be the final executable file that calls into the DLLs. To show these, we stereotype them all. Notice that because we're creating our own symbol, we can reuse the symbol. In this case, we use the DLL component symbol twice. If we have more executables, we can also reuse the executable component symbol. Okay, so now we can refer back to this, C++, but specifically we're talking in book 2. This is the all-in-one. Okay, flip the camera. Why does it do that? I'm like, flip the camera. They're like, no, closer. Like, no. C++ for Dummies is all-in-one. This is actually, it says right here, 6, right there, 6 books in 1. And so I'm in book 2, and book 2 is about UML. So here's the UML breakdown they're talking about just now for components, right there, and the library, etc. So the spy program is the executable, and it gets information from the DLLs. There's the DLs being the stereotypes. So one of them is the accounting library on to the left, and to the right is the math library, and then the further breakdowns on how things reside. And they're using the same kind of system that they used as far as like how it's mapped out that they expressed here. Oh, and boom, there's a light behind me, but it's thankfully not in my hand and a messy time. So okay. All right. So case tools. I don't even know. So that's the thing. One of the things I did back in like May or June was I was trying to look up case tools. I don't think that's like a thing anymore. I think those got phased out for better things. Anybody know? Again, case, capital C, capital A, capital S, capital E tools. Case tools differ on how you add stereotypes. So for many tools, you use a menu item. And in a dialog box that opens, you add a name for the stereotype. Then you choose the base class. Now, don't confuse that with what you normally think of as a base class. We're talking about, oh, okay. Again, if you're sleeping, that means in 2 minutes, because I'm about to be done with reading this section and calling it for yummy free time. But thank you for stopping by and for being interested, even though it's just boring reading time. So we're talking about meta information here. Case tools differ, etc. Add the stereotype. Then you choose the base class. Now don't confuse that with what you normally think of as the base class. We're talking about meta information here. Look at it this way. You have a symbol such as component. You're making your own specialized symbol based on a component called, for example, DLL component. Oh, okay, so that was called so that's why they made it. Okay. This DLL component is, in a sense, derived from the component symbol. Thus, the base class in this hierarchy is the component symbol. And so when you create a stereotype for a component, the base class is a component. Okay. Right then, I guess. Okay. Tip. Before you make your own stereotype, first check to see if the stereotype already exists. Perhaps you're reviewing the documentation that comes with your case tool and any stereotypes already available at your organization. Many stereotypes are already available in UML. For example, in the case tool we're using, executable already exists for the component symbol. Oh, that's good to know. Don't want redundancy. That's true. Alright, I hope you fell asleep by now, Ryan, because this is the last paragraph that I'm reading tonight. In figure 3-8, you can see how we use stereotypes to create. Oh, but if you want to fall asleep to something, do check out my previous live. The on demand is already on there. That's 2 hours. You will definitely fall asleep to that one. In figure 3-8, you can see how we use stereotypes to create a special DLL component symbol and a special executable component symbol. Notice also that we drew an arrow from the executable called spy program to the two DLLs called accounting library and math library. These arrows are dashed and have no stereotype associated with them. The dashed arrows indicate that they depend on the two libraries. Okay, yeah, the dash. It's coming back. That's something that we went over in advanced object-oriented programming. To show that the classes reside in the libraries, we use a dependency arrow, again as a dashed line, but we used stereotypes to show that these are residual forms of the dependencies. So again, this is a special version of the symbol, which we denote through stereotypes. Okay. Alright, I'm just not feeling like I'm doing a thorough enough job if I don't try to use that information to go over this thing again. So cleavage time again, I guess. Okay. Why does it just go in more? I'm flipping. They're like, no, close. All right, so right here, again, they're talking about the dash line. Let's see. That's messy. This is going to be messy. They're saying that the dash line means that, looking for the word dash. I'm very sleepy though. Hi there, where there? Oh, the dash errors indicate that they depend on the libraries. Oh, depending. Right. So they chose a dependent relationship when it's a dash. So in this case, we have the accounting, math, both being dependent. Well, technically the SPY program is dependent on both the accounting library and the math library. And effectively, the accounting library is dependent on the money handler and grubber and the lawsuit payoffer. And the math library is dependent on the complex number faker and the algebra tutor. What is going on that? I swear, there's some story, there's some lore behind this, but I am not a math hat and I do not have time to figure out the lore. That being said, he didn't have time to figure out either. That's why he retired, I suppose. And or just figured there's better opportunities doing other things. But he has creative aspirations. I think that's awesome. I also have some of those. I look forward to doing something with them at some point in time. But for now, dancing has been really fun. I've been enjoying that. All right, that being said, that is going to be it for tonight's reading of C++ for Dummies. Well, all-in-one for Dummies. So, hey, we got a little progress. Probably got more progress than my other live. If you're interested at all in catching the replay on this, please do. If you want to catch the replay on my other live I just did on Saturday, it's pretty Saturday, cool. There's also shorts. If you're interested in dancing time, there's regular videos for dancing time. There's mixed chicks. This is old content, mind you. I do waves. I come waves. I get bored. I move on to just watching YouTube. I love watching. I love to watching with YouTube. Not so much the making content. It's just a thing I do when it's a fun time to do it. That being said, Becky828 here, Becky828 TikTok. If you're interested in some TikTok dancing, it's different than what's on the YouTube shorts. And that's gonna be it. Signing off. Bye bye. Thank you for everybody who kind of to stop on by. And yay, appreciate that. I was kind of feeling kind of on the lonely and the bored, and I didn't want to fall asleep just because sort of thing. So thank you. Bye bye.